studies using a very long exposure over a period of several weeks. So we try to develop a sensitive animal model to demonstrate the adjuvant effect in the, using the ambient particles. So this is our animal model. So on day 1, we give animals some particles. On the dose we use in this model is only half microgram, so 500 nanogram. On day 2, 4, 7, and 9, the animal will receive intranasal instillation of 10 microgram of ovalbumin, which is a mouse allergen, plus 500 nanogram of particles. And then the animals will rest for about 2 weeks, and then they will receive secondary OVA challenge to get a full immune response, allergic response, and then they'll be sacrificed 48 hours later. So we use this protocol to conduct a study to look at the effect of ambient particles on allergic sensitization, the primary immune response. And you can see the top bar graph shows the bronchoalveolar lavage differential cell count. And these are the cells from the lung. And then you can see sensitization with OVA plus ultrafine particles induced a significant increase in eosinophils. Increase in eosinophils is a hallmark for allergic inflammation. And we also include a group in which the animals received the particle only, and you can see that the particle by itself did not have any effect. And we also look at the OVA-specific antibody production, and you can see with the particles, there's a big increase in OVA-specific IgG1 and the IgE production. So all these endpoints tell us that the ambient ultrafine particles at a very low dose can enhance allergic sensitization. So after we observed the effect of ambient ultrafine particles, we wonder if the fine particles can have the same effect or not. So we did a side-by-side study to compare the effect of fine and the ultrafine particle effect. And you can see the fine particles had no effect on allergic sensitization in terms of eosinophil infiltration in the lung. This is the bronchoalveolar lavage differential cell count. And the same is for the antibody production in the blood. And you can see the fine particles did not have any effect on OVA IgG1 and the IgE production. Those are the two graphs on the bottom. And also we look at this inflammatory mediators that's specific to allergic inflammation. And so ultrafine particles increased this L5, interleukin 5 production, but fine particles failed to do so. Because we give the animals the particles and the allergen OVA through intranasal instillation, then we look at the histology of the nose and the lungs to see where this allergic inflammation starts. So this is the histology of the nose. And you can see at the middle, the three pictures in the middle shows the production of mucus in the nose. And the left column, the pictures in the left column are from the saline-treated animals, and the middle ones, the animals are sensitized by OVA, and on the right side, the animals were sensitized by OVA plus ultrafine particles. And here you can see when the animals are sensitized by OVA plus ultrafine particles, there is a significant increase in mucus production as well as eosinophil infiltration. That's the lower right picture. We look at the eosinophil expression by doing immunohistochemical staining. So the same thing is in the lung, and you can see there's an increase in the mucus production and also in the eosinophil filtration. So here is what we looked in the nose and in the lung in generation 5 and 11. Okay, I skip this. And here we show that the fine particles has lower organic carbon content, and also they have lower pH level and the DTT activity. So it suggests that the adjuvant effect of the particles are correlated to the chemical content of the particles. This experiment, we just gave one intranasal instillation. We see the same effect. So that indicates we don't need too much exposure, particle exposure, just single dose of 500 nanogram is enough. And after this, we also look at the real life inhalation exposure study in a trailer in downtown Los Angeles. This is our protocol. We sensitize animals in the same way, saline, ova plus particles. But during the secondary allergen challenge, some animals receive ova plus filtered air, some animals receive ultrafine particles. And here you can see during the secondary challenge, when you give the particle can cause a severe inflammation in the animals sensitized by ova plus particles. And so also it increased some inflammatory mediator gene expression. And also this, I just want to show this one. This one shows that during the secondary immune response, when we give the particles to the animals, it will cause more severe inflammation deeper in the lung. And so this graph shows the long arrow shows the primary immune response, and the short arrow shows the particle effect during the secondary immune response. So it goes all the way down to the alveolar level. Summary of our studies. So ambient particles can act as adjuvant to boost both primary and secondary immune response. And the target site during secondary immune response normally is the distal lung. And the overall summary, so induction of oxidative stress by particle-associated chemicals plays an important role. And smaller particles are more dangerous. The adjuvant effect is closely correlated to the particles' chemical content and the oxidant potential. And the real-life inhalation during the secondary exposure could lead to a profound allergic inflammation deep in the lung. And also the relevance to humans, this boosting effect of ultrafine particle inhalation during the secondary immune response may provide an explanation for the asthma flares after a sudden surge in PM level. These are the people who are involved in the whole process. Thank you.
Thank you very much.